Okay, so now just some of our function terminology. So our polynomial has a function of rule type, some an x to the n plus some an minus 1 x to the n minus 1. In other words, we have a1, a2, a3, some coefficient of x or x squared, and the x value is raised to an integer power. Okay, so n has to be 0 or greater. There can't be a negative value. So in this case here, obviously n is 2 there, so it's an x squared, x to the 1, x to the 0, so it is a polynomial function. The same thing, x to the 4, x to the 2, so the degree of the polynomial is 4 in this one. But if you compare that to the third example, the power on that one is a minus 4, so that makes it not a polynomial. Our expansions, so if you remember our expansion rules, we can do it the long way. X plus 3, that's the same as x plus 3 times x plus 3 times x plus 3. But in some ways, do it that way, it's the same as x cubed plus, so it's the first term squared times the second term plus first term to the power of 1 times the second term squared plus first term to the power of 0 times the third term squared. So you'll notice it's x to the 3, x to the 2, x to the 1, and really that's the same as x to the 0. 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. So the powers increase and decrease by 1 as we go along. The only thing that we've got to be aware of is the coefficients out the front are 1, 3, 3, and 1 every time. So they're all multiplied. So then my final rule is x cubed plus 3 times 3, which is 9, x squared, plus 3 squared is 9 times 3, which is 27 times x, plus 3 cubed, which is 27. If by chance we have a negative sign inside, it just means that wherever my last term, x to the 1, x to the 3, is raised to an odd power, it'll be a minus, it'll be a subtraction sign. So following that through here, that's just simply equal to a cubed plus 3a squared b to the 1 plus 3a to the 1b squared plus b cubed. Okay, just remembering that little pattern. This one here, 2x cubed plus 3 times 2x squared times 4, 3 times 2x times 4 squared plus 4 cubed. So the powers change as you go. 8x cubed plus 3 4s are 12, 2 squared is 4, 48x squared plus 4 squared is 16 times 3 is 48 times 2. Oops, better rub that out. So it's going to be plus 96, isn't it? Plus 4 squared is 16 times 3 times 2 is 96x, and 4 cubed is 16 by 4, which is 64. Okay. So I guess equating coefficients is one nice way we can try and solve for unknowns. For any two polynomials to equal, then both polynomials have to be identical, which means the x squared terms have to be the same, the x cubed terms have to be the same, the x terms and the constants all must be equal. So if we look down here at this example, the only way this expression here can equal that is if I expand the right-hand side and we get the same answer. Okay, so there's two ways we can approach it. I think if I just expand this whole term here, I get x cubed plus 3x squared plus 3x plus 1 plus b. So if we look at the x cubed coefficients, on the left-hand side, the x cubed coefficient is 1, and that has to equal the x cubed coefficient on the right-hand side, which is just a. Okay, and so the only other place the b occurs is at the constant. So the constant on the left-hand side is 8, and that has to equal the constant on the right-hand side, which is a times 1, which is a, plus b. And since a is equal to 1, b must be equal to 7. So therefore, a is equal to 1, b is equal to 7. So it's a case of expanding the terms, get them to look similar, and then equate the coefficients, try and match off the x squared coefficient, the x coefficient, etc.